Hello everyone, welcome back. We're gonna continue on the topic of machine control PLC programming. At the end of the last video, when we talk about the drill control, I talk about two problems, right? So one of the very easily made mistake is the double coil syndrome, right? So that's one thing you have to be careful, otherwise that's going to be a huge problem because we have two different modes, right? So one is the auto mode, one is the manual mode. But whenever you want to energize the same output, like over here, you want to parallel them in branch, right? Top branch and bottom branch. So you don't want to separate them into different rounds. That's gonna make mistake with the double coil. And some people may ask, is it possible that I separate two branches into separate routine? So then we can use GSR to control the calling of the subroutine. That solution may work, but it's not a good solution because when you do so, you have to be careful with what else you put into that subroutine, and the scheduling of your subroutine become complicated. So if you don't pay attention on that, you're gonna make other mistakes, right? So better to have all the output into one run, then all the situation to energize this same output into parallel branch. So that's the first thing, first problem we solved, right? On the second one, we talk about the initial position, right? I demonstrate if you don't include the initial position check, your drill will be stuck in the middle. So like over here, when you're trying to energize the extend output on here, not only you need to check this over here, that's destination, right? So you need to move to the destination position, right? So you also need to check the initial position, right? Because a machine is running in auto, whenever you want to move the drill to the extend position, you need to make sure your motion start from retrack, right, all the way at the top. So in the same way, when you try to energize the retrack output, you need to make sure your drill is you start at a extend position, right? So those two, that's what we call the initial position check for each motion. And after you check the initial position, notice here, this is second branch, to bypass this condition. Because whenever you whenever you energize the extend output, this retrack process will turn off once the drill start to move, right? In order to keep going with the motion, you need a bypass by the output. Typical 3-wire control application, right? So we already learned that. All right. So let's see if this solution will work or not. All right. So this is the interface, and this is the program it's running. Right. Right now you can see we don't have any mode energized, and both output is de-energized. So first thing, we need to set into manual mode. Once we energize the manual mode, we can use the buttons to extend and control the tooling. All right, so let's do it on here. So first, I'm going to press manual mode button. So that will be pressed, and we'll go into manual mode. All right, so we're in manual mode, and in the same time, you can see here indication is here. Now, if I press actually I can press either of the button, right? So I want to raise up the drill to the top, so that's why I need to press retract button. Over here, that's the raise button. So if I press and hold this, for sure I will see the drill go all the way up. Then the retract proxy is made, right? So over here you can see here. So that's on. Retract proxy is on. That's over here. So now we are ready to go into the auto mode. Right? So we're going to auto mode by pressing this button and switch to auto. Now we can load the part. Once we load the part, you can see here we start from initial position, going to the extend, and then bypass on that, right? So then drill start to retract. Now we see some movement, right? So, but the problem here, watch over here, we have another problem, because this is the second hole the drill put on the part, right? So then let's start on the third cycle. So the same part, we load the part, but we want only drill one hole on the part. But now the machine won't stop. It just repeat during the cycle. So this is what you see in the real time, the program. So machine in auto mode, then we have these two output. Alternatively, turn on one after the other. So there's no stop. So what we want is that we start from the retract position and going to the bottom, finish the job, reach back to the home position, then stop. But clearly there's something missing on the program we have right now. So this is what we have. Watch these two rounds, right? So this is what we have right now, but we need to add something else. Okay, so that's just let me stop it. Stop in the manual mode. Then I can pick the part, right? So we clear out the machine. Now we go into the different solution. So in this solution, we need to add something else on the existing logic. What we want to do is to add a sequence bed. So over here, I'm choosing a different subroutine now. Now let me open this. So in this improved design, we add one new tag called extend memory. See here, extend memory, large and large. That's what we add on the sequence, because as I just explained, drill at the top will start to extend to the bottom. Once we get to the bottom, we want to memorize. We finish half of the cycle, so that represented by the latching of extend memory bed. So you can see here, whenever the extend proxy made, the drill reach to the bottom, we will latch this memory bed. And of course, when the drill start to extend, this bed was 0 at the beginning. So that's why we choose exam off to get logic 2. Then we energize this, we reach to the bottom, then we latch the memory bed. Once we latch memory bed, that's going to be true. Then the drill will start to retract. Right? Once retract to the top, this memory bed is still 1. It's still latched. Right? And that will make sure this instruction become false. Then the extend output will never turn on unless you turn this one off. Right? So you may ask, when do we turn this memory off? That's the unlatch. So whenever we have the retract position, the drill all the way to the top, after we remove the part. So you can see here the part present, exam off. So when we remove the part, this instruction become true, then we will unlatch the memory bed. Right. So let's try if logic working on there. So again, going to manual mode, I will home the station by raising the drill all the way up. So now we are ready to go into auto mode. Go into auto mode, then we load the part. So watch the over here, this extend output, everything is true except for the part present. Once I load the part, this become true, we will see that extend. Right? Because right now this memory bit, the current value you can see here is 0. Right? So then we will watch for this latching happening. Alright. So I'll load the part, this become true, drill start to going down. Once reach to the extend proxy, you can see here that memory bit become latch. Once it's latched, you can see here this instruction will never get true unless it's being unlatched. So you can see here this instruction here, this memory bit guaranteed we will not repeat the second cycle on the same part. Okay. So we finish one part. Now if we pick part, the part present right now is 1. That's why this instruction is false. Once we pick the part, remove that, it becomes 0, it will become true. That will unlatch the memory bit back to 0, and this one ready to become true. But in the same time, because we remove the part, this gonna lose the continuity. The drill will not extend. We'll wait for the second part being loaded. That's what will happen once we pick part. You can see here memory bit being cleared and part present is not there. It's just waiting for us to load the second part. Then the machine will start. They will repeat the second cycle. We'll wait to finish this, give you a chance to look at it. Then the drill stop. Right. So it worked perfectly. Alright, let's just go back here. Alright, on the slide, on the next slide, I print out the program. Right, so that's what I just showed you on there. I also emphasized where do we put the memory bit. Right. So this memory bit basically is the sequence we want to add to the machine. Right. So whenever we extend, we want to energize this memory bit. So we have this sequence, then we will not repeat. So this is the first time I introduced this concept, the sequence bit. Right. And let's look at the next one, next slide. So what I'm trying to show you here is that sometimes we use the diagram to analyze the problem. So similar to the timers, right? The timing diagram is a very good example at the start. But for here, I'm showing you the motion movement. Right? Some people call that motion replacement diagram. So over here, I have a drill. That's the tooling. Start from retract position, motion going to the extend position first, then go back to the retract position. So at this point, we said the drill is cycled. So that's what we use the term to describe that. So in the same time, we have two sensors, right? Proxy sensors, retract and extend. So you understand that at the beginning, when it's retract, that proxy sensor is on, then will turn off. And then when you go back to the home, it turns on again. The offset is the extend proxy. When you get to this step over here, it turns on here. So that's why this is the trigger to touch the extended memory. It doesn't necessary to use the OTE to not necessary to use OTL, right? In the program, in the previous one, in the program, we use latch unlatch to do that. But you can also use the output energize to work on the bit, right? For this, you can also refer the textbook I just mentioned before. You can look at there. All right. With the exercise, let me see. Yeah, I think I have some time. I can try to illustrate by that. So we don't have to use large and large all the time. So for example, here I have a tag called dummy. It's a double integer tag. I can use the 32 Boolean bits inside this double integer to illustrate the same logic. The reason I want you to understand this is that large and large in some situation is easier than the OTE, and sometimes vice versa. Right? So you have to see what situation you have right now. And the other difference between large and large with OTE is that with power loss, the large will keep the memory bit value become 0. Right? So that's called retentive. Right? So let's try that. So if we want to get equivalent logic, probably we first to do this. So we will have this condition move to here, and then we energize one of the output. Like I said, I'll just use dummy dot 0. That's the one of the Boolean tag within the double integer. Right? So I'll finish this one, and so we first to get this condition with the unlarge condition. Now we need to add another run. So with this run, we will energize the let me try this. So we use dummy.1 to simulate this extended memory bit. I don't want to use the same tag, otherwise we'll have a double coil syndrome. Right? So that's why I use this as the intermediate result and use .1 as the compare result with the extended memory. So what we want to have here is to this as the typical 3-wire control, this as the start condition. Then we should have a exam off of the less dummy with 0. Also, in order to have the seal in, right? So we have to bypass here. Then we can use the 3-wire control logic to do the same thing as large and large. Right? So I just want to show you, logic-wise, they are identical, equivalent. It just in some situation, one way is better than the other. All right, so let's just try if we can get the same result. All right. Let me see here. Let me start the demo. Here, we'll remove the part. All right. Let's see if the dummy.1 work exactly the same way as the memory bit. So I will load the second part. We watch here, whenever this one energizes, this large, that should also energize. Yeah, you can see here, dummy.1 is also energized. So they have the same logic result as being 1. Don't be confused by the green bar on here. Let's just simply tell you this memory bit current value is 1. Right? So that's what you see on here. Then if I pick part, then this .1 being reset to 0, and same thing for here, reset to 0. Okay. Let's go back to here. The sequence bit. Alright, okay, so after I explain the sequence bit, then we will have some other concept or term I need to explain. what we have the previous result, the logic like this, it will work for simple tooling. Like for example, we only have one tool for drill, so that's big deal. That's not a big deal. But in our following example, we'll have more than one tooling, and in the real situation, real world, probably there'll be more than two, lots of them, and then we'll have to have more other logic built in to guide the logic running smoothly. So that's why I'm saying here, when there's more than one tooling, we want give the operator the opportunity to use the push button to control each individual tooling. For example, later on we're going to add a clamp, right? So you need to have a separate button to control both tooling, or if you use one button to control everything, right? So that's the flexibility we want to provide. And also we will have a home position with both tooling and also cycle button, because if you only have one tooling, it's very straightforward. When you have a part present, you start working. But when you have more than one, you have to watch out both tooling if they are both in the home position. Once they are there, you press one button called cycle. Remember I explained the cycle, so CycleStart. Right, so that's one button. And tooling, I already explained that. Let's see here. Anything else? Oh, cycle. I think I already talked about that. Each cycle station process one part. Right. All the toolings, clamp and drill, both tooling will have their own CycleComplete indicator. So drill cycled and clamp cycled. So drill cycle will be from the retract position going to the extend, then go back to the retract position. And same thing for the clamp, right? So on the station level, we should have a indication on the CycleStart and CycleComplete. So that indicate the full cycle. The sequence will be clamp close first, then drill come down. When drill finish, raise up, then clamp open. That's a specific sequence we want to have once we add the clamp. All right. So the other thing I need to talk about is that when we need to check the tooling position, sometimes people think, okay, for example, if I want to get extend memory, we only need to check one condition, extend proxy. You can see here, that's what I did on this one. Again, this is very rudimentary, very basic setup, right? So in the real world, sometimes the sensor become dirty or being interfered by other things. So for safety reason, we have to have both sensors check in the same time. So we want to have extend on and retract off. Remember we have that interlock, similar situation for both buttons. Then for the sensor, we want to do the same thing. Check both sensors in the same time. Then not only that, we need also add some buffer as a timer on here. Now I gave 1 second, and then whenever this 1 second finished, we want latch the memory bit. So this is what you will see later on in the example program. We check both sensor, and also we have a timer delay. So that's one thing we need to look at it. The other thing is that how do we organize your program? So you can see here with the program of drill station, I will have 5. You can see here 5 routines. So one of them is main routine. So we already understand from the main routine we use JSR to call the subroutines. So subroutine we have 3 of them, actually 4 of them: input, station, and tooling and output. And the reason we have R1 and R4 is what we call buffer I/O routine. Alright, so we will talk about that later because that's related to the real input-output device and also related to the network communication. So for now, we just need to focus on R2 and R3. So R2 will be the station routine. R3 will be the tooling. So if you look at the main routine, we just use 4 different JSR to call the subroutines. Right. Again, I just want to introduce the basic format we're going to use in the following projects. Over here, I gave you the program printout. So with R2 station, right, remember here, so that is one of the subroutine here, R2 underscore station. Divide into 3 parts. The first part handle the mode: auto mode, manual mode, cycle request, CycleStart, CycleComplete. And part 3, handshake. The handshake is the interconnection between the stations. Right now we only have 1 station, so we don't have to worry about handshake, but we need to look at the first 2. Right, so pretty straightforward. We look at this before: manual mode, auto mode. The only thing we add on this routine is we have a station dot to home. Right. So currently we only have a drill one drill on there. So then, if you can see here, we check both sensor. Retract is on, extend is off. And if you want, you can add a timer. Right. But I didn't include on here. I include in the following logic. Right. You will see that in later. So this is the first part. We handle with the manual auto mode and home position. And after that, on the part 2 with the station, we have a cycle button from the operator. Right? So from over there, we use the 3-bar control to energize an intermediate result called cycle request. And this cycle request, you can see here, follow the line, you can see here, carry on the second run. Once we are in the auto mode, cycle request being made. If part is there, we start from home. Cycle not complete, we start cycle. This cycle start will later on use in the tooling. And over here, we just bypass this to home, because you can see here when we start the motion, the drill is at home. But once you energize CycleStart, the drill is gonna move. Once it's moved, you lose the home. So that's why you need this bypass to keep going. And once we start everything on the cycle, we have to somehow make this CycleComplete become 1. So that's what we're doing over here. So once we have CycleComplete, the cycle will stop. Right? Then how do we define CycleComplete? You can see here, drill cycled and go back to home. Cycled, that means start from retract, going to extend, then go back to retract. Then over here we also include the part pattern. Right? You see the demo on there. Once the cycle complete, unlatch the sequence bit. So this is the sequence bit we will have later on in the drills, in the tooling, in the next slide on the tooling routine. Right. On this slide, that's the R3 tooling routine. Right. So we have here is the R2, and now we have R3, routine number 3, tooling. So with tooling, same thing, we divide each sequence into 3 parts. Right? First, we handle with the sequence, then we energize output, then we update the status. Right? So if we keep in the same way, so we don't have to worry about if we miss anything. Right? So let's look at what we have here. Remember, on the station, it gave the CycleStart signal. So once we have the CycleStart signal, we just need to check the sequence bit. So we're trying to energize the extend output. At that moment, the memory bit is 0. The cycle bit is 0. So that's why we have both here as a condition in order to energize this intermediate result. And that intermediate result will carry on with here. So the reason we carry on over here, because when we energize output, we don't want to have a double coil. We need to have manual and auto in the same run over here. Okay. So that will carry on, and then both have the condition with the destination extend proxy. And retrack output on here is the interlock for the not here, for the next sequence, next slide on here. Right. So because you can see here, that's extend output, that's retrack output. They both they cannot be energized both on in the same time. Right. Then the last run over here is the status. The status we want to update. At the end, we want to large the memory bit. Right. So if the drill extend to the bottom, and then the retrack is not on in the same time, then we delay 1 second. We large the memory bit. So you can see here at this sequence, at the beginning, this memory bit over here is 0. Right. So that's the condition to start. Then we check other condition to energize this, wait until the drill extend being made, then we energize this memory bit into 1, value of 1, in contrast of here. Right. So that's why we call sequence energize output. We check the sequence, then we energize output, then we update the status. So the next one, we will raise up the drill. So for the retrack, right? Because at the end of this first sequence, this memory bit being enlarged, so we have value 1. So that's why we have exam on. But the cycle is not complete, so that's why it's exam off. So again, intermediate result, and carry on the second run. So that's the real output. All this are same as before. So at last run over here, we have the memory bit being enlarged, but in the same time, we tell the station the drill cycle will latch on here. So same thing as here, check both sensor, and this part is exactly the same as the previous sequence. But over here, I ask you a question. Must insert the sequence bit here. Why? So if you look at the logic, if we don't have this part on here, the drill retract proxy on, extend proxy not off, it's off, then that's exactly where we start. That's the home position, right? So if we don't have this condition at the front, we won't start, because the home position will latch the cycle. So you are not going anywhere with that condition. So that's something I want to pay attention later on when I do the demo. Right? So let's start demo on here. Move to the second one. Okay, so now you can see here we add more indications. Right? It's homed, CycleStart not on, request not made, the drill cycle is not on. Okay. So we want to CycleStart, and then you can see here made request is on. I'm going to show you the logic here. So that's the station. You can see here auto mode and to home, so that's here. Request is here because I just pressed the button. But the CycleStart, you can see the CycleStart here is not on. Same here on the HMI. So what is waiting? It's just waiting for the part present. Right? Part present on, homed, not complete, we will start the CycleStart bit. And that CycleStart bit will go into the tooling. So if you look at on the tooling routine, the first one is to check CycleStart. Right? So we'll look at here. We'll trace that later on once we load the part. Now we load the part. It's on. We have a CycleStart. Now you can see here, CycleStart is on. Memory bit is not on. We have this memory bit. It's here. Right now it's on the retrack output. It's going up and then stop. Why stop? Because here it's being latched. The drill finish cycle, if you go back to the station and the drill cycle is on, and no, it's still here, right, on the tooling on here. So yeah, let's look at here. Because it's cycled, right, it will stop the second repeat cycle, right? So it's just waiting for the part being removed. So once part being removed, we'll have CycleComplete that will cut off here. So let's see here, cut off. Then once we have CycleComplete, the drill cycle is also unlatched, so it's ready to repeat again. Alright, I'm gonna do a second part so you can see the movement. We load the part, we have a CycleStart, then we go into the tooling here. Right now it's extending, and then memory bit will be latched. Once it's latched, move on to the cycle, the second sequence, and then drill cycle finished. Drill cycle finished, then if you go to the top, that will block the repeat cycle. Right. If you go to the station, right now it's just waiting for part being picked up. Once part being picked up, this will be de-energized, this will be de-energized, become 0. So it's waiting for the third part. Alright, so that's the end of the this video. Alright.